we are given the function f of x is equal to 1 over x, and then we're asked to calculate the derivative at a given point. Now the derivative of this thing, in other words, what we want to find is f prime evaluated at 2, okay? And so there's three different ways, God bless you, there's three different ways I could approach this. In the textbook, one way we could do it is this way. We could take the limit of f of x minus f of a as x approaches a all over x minus a. Now the problem with this function is that if I plug in a for x, I'll get a minus a on the bottom, which is 0. Which is the same problem we run into when we let h approach 0. So this is the same setup as the other two ways to find the derivative. So what I need to do then in the next step to find this evaluated at 2, what is f of x? 1 over x. Minus f of a. What's f of a? 1 over... Well, let's write it as 1 over a.
Wait, see why you do that?
Well, I could plug the 2 in here. Or I could leave it at a and plug the 2 in at the end. It doesn't matter. Mr. Adams is doing it this way on purpose to give you guys a little bit of algebra practice. So now what did we do yesterday? Do you guys remember what we did yesterday? What would make this a little easier for us?
Substitute for the a, and then get rid of the x, so you have 1 half.
Yeah, we can do the common denominator. So if I hit this with an a on the top and bottom, and I hit this with an x on the top and bottom, I'm going to get one fraction. So in the next line, I get the limit as x approaches a of a minus, oh wait, this is an x, x all over ax, right? All over x minus a. So this is the numerator, and this is the denominator. Now there's a little trick we could do is I could write this over 1, right? And so now I'm taking a fraction and dividing by a fraction, so what is that really? What do I do in the next step? I can multiply by the reciprocal. So if I say f prime of 2 is equal to the limit as x approaches a, now I've got a minus x all over ax, and then I multiply by the reciprocal. But before I write the reciprocal down, so I'm going to have a 1 on the top, and then I've got x minus a, but I'm going to switch that around. Could I say minus 1 times a minus x?
No, you couldn't do that.
Why couldn't I?
It'd be positive.
Yeah, so,
Oh, yeah, you can. Because you're going to distribute the negative through and get negative a plus x, which is the same thing as x minus a.
now why would I do it that way?
So you can,
Because by pulling this negative out, I can cancel the a minus x with this a minus x up here, right?
oh, yeah.
Does that make sense? So on the next line, now I've got f prime of 2 is equal to the limit as x approaches a of 1 over negative a times x.
Can you slide up a little bit?
Yeah. You guys with me so far?
No, where'd the denominator go?
It canceled.
You just cancel it out.
Because you pulled out a -1.
No, I mean like, it was,
So So where's the?
Okay, I went a little too fast. Let me backtrack so you guys can see it. Now, these problems are kind of rigged up, but when Mr. Adams saw this, and I knew that I was going to multiply by the reciprocal, I noticed that this is x minus a, and up here is a minus x. So what I did is I factored out, in other words, this, if I take x minus a,
You just added that.
I want to make it look like a minus x. So if I factor out a negative 1, then this changes to positive and this changes to negative. So I could say negative 1 times a minus x is the same as x minus a, isn't it?
So did you times the bottom then by 1 over x minus a, you just didn't write that part?
Well, what I did was, is this is the same as this. So this is the reciprocal. The only difference is that I factored out a negative 1 here. When I factor out the negative 1, that gives me a minus x as a factor, and this is a factor, a minus x. So then I can cross cancel those. Does that make sense?
So you did that just so you could cross cancel?
I did that just so I could cross cancel. Maybe we'll write it all. Let's write out every step so you can see it. Okay. So if I say f prime of 2 is equal to the limit as x approaches a, well, we know that I could do this, right?
So that whole thing is a numerator, right?
Right. The problem is I'm not getting any help here. When I multiply that through, at some point I'm going to have to plug in my a for x. When I plug in my a for x, I'm going to get a minus a, which means I'm going to have 0 in the denominator, so I can't do anything with that. Does that make sense?
So you want to get rid of that.
So I noticed though that the only difference between x minus a and a minus x, and if I rewrite this on the next line, if I rearrange these, I get negative a plus x, right? Can I cancel those? Well, not the way they are. Okay, so do you understand where this came from? This came from this. When we take a fraction and we divide by a fraction, we really multiply by the reciprocal, right?
Oh.
Okay, so now when I go to multiply by the reciprocal, I know that at some point in time I'm going to have to plug in a for x. Now if I plug in a for x, what happens here?
You get 2 minus 2 and you have 0 in the denominator.
You'd have a minus a, which gives me a 0 in the denominator, right? But I can't help but think, wouldn't it be nice if there was some way to cancel this with this? Because I need to get rid of this x on the bottom of the fraction. So I flip-flop them around and I say that's the same as minus a plus x. Okay? You guys with me so far? So now what I'd like to do is make this a positive and this x negative. Can I do that? Yes. If I say a minus x over ax times the quantity 1 over, if I factor out a negative 1, this is a minus x. Does that make sense? So now that I've done that, I can cancel the a minus x. Notice that that negative 1 is still on the bottom though. I can't cancel out the negative 1, it has to remain. Alright, so I just kind of skipped that step, and I'm glad that you asked because now we know exactly where it came from. So when I wrote it this way, I said, wouldn't it be nice if I could make this a positive a and this a negative x? Well, I can if I factor out a negative 1. When I factor out the negative 1, then I can cancel this with this. And what I'm left with is the limit as x approaches a of 1 over negative ax, which is the same as 1 over negative a, now I'm going to plug in my a, times a, or negative 1 over negative a squared.
Wait, why is it negative AX? Because doesn't the negative like distribute?
Yeah,
AX?
so we got negative 1 times ax. That's how I get negative ax.
Wait, that wouldn't be negative a squared.
Why wouldn't it be? It's negative times a times a. I could think of this as negative 1 times a times a.
But
But wouldn't
When
that be,
when you
that'd be
square
it.
wouldn't that
it,
be
That'd
negative
be
a
positive.
times negative a?
Yeah,
that would be a positive.
that'd be, one would be a positive, one would be a
Yeah, it's
negative.
supposed to-
It's not negative a times negative a, it's negative a times a.
But when you say negative a squared, that's what you're saying. it's
Negative a times negative a.
No, that's not. It's not in parentheses. It's the negative of whatever a is squared. Order of operations, right? What I did here is I factored out, so negative a is the same as negative 1 times a.
But let's say you put 2 in for a, negative 2 squared is gonna be positive 4.
No, it'll be negative 1 over 4. You're getting ahead of me, but yeah. So on the next line, so trust me, this is mathematically correct. When I finish this problem, we'll do some example problems and I'll solidify that. Let's just finish this one for now. So what I've got is that f prime of 2 is going to be negative 2 squared. Order of operations says that I'm supposed to square the exponent first, so I get negative 4. 1 over 2 squared, and then I take the negative, so it's negative 1/4. Okay, now how could I verify this graphically? Well, we've got to remember that our original equation was 1 divided by x,
But you,
and let's graph that. And what we were trying to figure out was, what is the slope of the tangent line at x equals 2? Now, your calculator will do that. If I hit second trace or pull up the calc menu, dy dx is the derivative evaluated at 2. And I should get negative 1/4. Is that negative 1/4? Any questions other than this negative business down here?